This video is on slightly more difficult equality of complex numbers questions. I'm starting off with a fairly easy one though. So you'll see here that I've got a bit of a jumble here of an equation. I need to tidy it up slightly. And my goal is really going to be to have my unknowns on the left and my known complex number on the right. So what can I do over here? Well, I can say a plus bi equals to, I can leave the right hand side as it is for the second. I'm going to bring my minus 2 across and make it a plus 2, and my 4i across and make it a minus 4i. And then tidying up a bit more on the right hand side, I can say 3 minus 3i plus 2 minus 4i. Finally, tidying up slightly more, I'm going to say 5 minus 7i. Don't forget, the goal in these questions is to figure out the unknown coefficients. So in this case, a is equal to 5 and b is equal to minus 7. You may often find in questions of this type that they will say to you that the a and the b are elements of or in the question that they pose. And of course you can see here that the a and the b that I get are real numbers. You'd expect that to happen generally. So, second example. So this time I've got a little bit more going on, and I'm going to have to obviously multiply my brackets out first of all. So I'm going to have 4a plus 2ai plus 3b minus 2bi equals to 10 minus 2i. Now, on the left-hand side, I've got quite a number of terms there with unknowns in them. On the right-hand side, I have all my coefficients, both my real and my imaginary. What I'm going to do on the left-hand side is I'm going to group my real terms together, or you can just underline them to identify them if you like. So 4a and 3b, and I've got my real term on the right-hand side. And then again, identify the coefficients of my imaginary terms on the left. So 2a minus 2b, and on the right hand side I've got minus 2. So I'm going to be able to make two equations actually this time. So I'm going to be able to say 4a plus 3b equals to 10, and 2a minus 2b equals to minus 2. And clearly here I haven't got as far as a solution for a and b yet. I'm going to have to use simultaneous equations to get there. So pause the video for a moment, solve the simultaneous equation, see what you come up with, and then check your answer. And you should find that a is equal to 1 and b is equal to 2. Another question of this type might look like this: express in the form a plus bi, and notice this time where a and b are elements of or, the square root of 3 plus 4i. So to begin this question, the first thing that I should do is note that they want me to write it in the form a plus bi. So this has to end up being equals to a plus bi. Now, having a square root over a complex number isn't going to be the easiest thing to deal with as it stands, but I can get rid of it by squaring both sides of my equation. And when I do that, of course, I'm going to eliminate the square root on the left-hand side. Just be careful squaring out the right-hand side. I'd suggest pausing the video now, doing that, and seeing where you end up. So again, just note, when you square out a bracket, square the first term, first by second by 2, square the last term, and of course this time that involves squaring both the b and the I. And here we see the I squared popping up again. Anytime we see I squared is equal to minus 1. So we're going to replace that I squared with minus 1 and do a little bit more tidying up. So with the I squared replaced, this is how it looks. And then I will continue to simplify a little bit more. And just note that as I've done that, I have grouped the real terms together and the imaginary term is at the end. As before, I'm identifying the real component on the left-hand side and the right-hand side, and then the imaginary coefficient also on the left-hand side and the right-hand side. And I'm going to be able to create two equations from this. And at this stage, I'm basically doing the same thing as if I was solving a linear and a curve equation. So pause the video and attempt that, see how you get on, and then unpause and check and see if you were correct. So I'm going to start by taking the simpler of the two equations, and I'm going to write one term, one unknown a in terms of the other. So I'm going to say here that, well, 4 over 2b equals to a. So I can simplify that to say a equals 2 over b. And what I'm going to do then is I'm going to take that 2 over b and I'm going to replace the a in the other equation. So I'm going to say that 3 is equal to 2 over b squared minus b squared. I wouldn't be a bit surprised if I ended up with a quadratic at some point in this. So I'm going to end up with 3 equals to 4 over b squared minus b squared. I'm not overly keen on the fact that I have a b squared in the bottom, so I am going to multiply my entire equation across by b squared, and that is going to give me 3b squared equals to 4 minus b to the 4. So it's a quadratic, but it's a quadratic with a power of 4 as opposed to a power of 2. So b to the 4 plus 3b squared minus 4 equals to 0. I want to factorize this. It's going to be b squared plus 4 minus 1. And then solving this, I can say that, well, b squared plus 4 equals to 0, or b squared minus 1 equals to 0. That would mean that b squared could be equal to minus 4, or b squared could be equal to 1. And that means that b could be equal to the positive or negative root of minus 4, or b could be equal to the positive or negative root of 1. Now, at this stage, think back to the terms and conditions of the original question. Is there an issue with either of these solutions? The issue is that if I evaluate the root of minus 4, I'm actually going to get an imaginary result. But I was told at the beginning of the question that a and b have to be elements of R. So I actually can't accept that solution. So that is gone. But I can accept the root of 1, and that can give me a positive 1, or it can give me a negative 1. And now that I have two solutions for b, I can pop them back into a equals 2 over b and evaluate a. So a is going to be equal to 2 over 1, where I get 2, or a is going to be equal to 2 over minus 1, and so I could get minus 2. Oop. Don't forget, they asked me in the original question to write my answer as a plus bi. So that just means combining my a's and my b's correctly. So my solutions at the end are going to be 2 plus 1i, or minus 2 minus 1i. Sorry, I'm falling off the end of the page there. 2 plus 1i, or minus 2 minus 1i.